Hey gang, so this is page 13 at the bottom, the antiderivative. Now I know we kind of did this in class the other day, and so we're just going to kind of go over it and give you some more definitions and more rules. So if you recall, when we did that derivative, we did f of x equals, let's say we have some function a to the nth power. And just in general, if we want to take the derivative of it, we would take n and multiply it times a, so we would say a times n, and then we would say x, and we would reduce the exponent by 1. That was our general rule for finding the derivative. So let's take, let's just do this. F of x equals 3x squared plus 2x. F prime of x, give you a second to do that. Sorry, my pen had something on it. 2 times 3 is 6x, reduce 2 to 1. This is 1 times 2 is 2. X to the 1 minus 1 is 0. Anything to the 0 power is 1. So this would be my derivative. All right, I'm going to zoom that in just a little bit. I feel like it's still not doing too good. Okay, that's a little bit better. Okay, so here we go. So, like I said, we did this the other day, but let's make sure we followed it. Example 25, find the possible function that f prime of x equals 7x to the third. Okay, so if f prime of x was this, what could I have started with? F of x, well, if this is going to be to the third, I know my function needs to be to the fourth, right? That's the only way to reduce that by 1 and get to a third. But that would mean the derivative of this one, f prime of x, would be 4x to the third. And I need 7x to the third. So you're probably thinking, oh, well, Mrs. Dean, what if we just put a 7 on the top? So something like 7x to the fourth. And already you go, well, 4 times 7 is 28. So I can't do that. But what if I put a 4 on the bottom? Then 4 times 7, those 4s would cancel out, and I would just have a 7. So let's see what this is. F prime of x would equal 4 times 7 would be 28 over 4, x to the third. 28 divided by 4 would be 7x to the third. Perfect. That worked. Okay, now let me remind you though, could I say f of x equals 7 over 4 x to the fourth plus pi? Okay, what's the derivative of that? Well, let's see. 4 times 7 over 4. We already have established that f prime of that would be, the 4s would cancel, and so I have 7x to the third. The derivative of a constant is 0. Hey, those equal the same thing. So that does work. So then we kind of made this rule and said, well, I could add anything I wanted. I could subtract 1. I could add 100. I could say plus 10 times, or times 9 times 10 to the negative 9. I mean, I can put whatever number I want right there. So we came up with this general rule the other day, and we said 7 over 4, x to the fourth, plus, and then we said, what if I just say c? Where c represents some constant out there in space. I don't know what it is, but it's just in general, c is some real number that I add on to the end of my function because I don't know what it is. Maybe I can figure it out, maybe I can't. But that is my function. And that is the antiderivative. Now, we are going to get more specific with that. But as you turn the page, I've got a whole bunch of little examples. And let me pull this here. All right, so here's what I want you to do. Find possible functions that give you the following derivatives. All right, again, I keep trying to get this in focus. Let me turn my light on. Maybe that will help. Let's see if that helps it get a little bit in focus. Okay, So I'm going to take this first one, and I'm going to say 3x squared. Well, if I'm going to have a squared up there, then that means that f of x must have been x to the third, because I'm going to reduce that 1 to get there. And I have a 3 in front, so wouldn't, if I took the derivative of that, be 3x squared? Yeah, but I need to give possible functions. Possible functions. I don't want to say plus c. Let's say, I'm going to say minus 1. Or I could say f of x equals x to the third plus 10. Those are just some possibilities. So there's no right or wrong answer. I'm looking for this in the front. Anything can go on the back. Okay, so here we go. F of x equals 6x squared. So that means I had to start with a cube right there, right? But 3 times what would give me 6? 3 times 2 would give me 6. And I reduce that. There we go. So this part gives me this, but I need something on the end. It can be anything you want. I'm going to go ahead and put C because you can put anything you want there. I am not looking for C as an answer, though. I'm looking for actual possibilities. Plus 10, minus 10, plus pi, minus E, anything you want. All right, f of x equals, since I got x squared on the derivative, I need to have x to the third to start with, but I'm noticing that there's nothing left here in the front, which means when I multiply 3 times whatever's here, the 3 went away. In order to do that, I need to make this 1/3. 3 times 1/3 goes away, reduce this, and I get squared. And then again, you can put anything you want. You can always put like plus 10 every time. It doesn't matter to me. Hey guys. All right, so let's try the next one. F of x equals, now I ended up with x to the 4th, so I'm going to have to make this to the 5th. But I have to get a 5. And 5 times, what would give me 5? Oh, can I just say 5x to the 4th? Yeah, that one's actually a pretty easy one. So I'm going to start with this. I'm going to say plus c. Again, you're going to give me an actual possibility there. And now the last one, f of x equals x to the 7th. So I need to make this x to the 8th. 8 times something right here gave me a 3. Well, I'm going to say that this must have had a 3 already here and an 8 on the bottom, because 8 times this, the 8s would cancel out, and I would have 3x to the 7th, which is what I need there. And then I need to have that constant. Again, you're going to put something there. I don't care what it is. Just put something other than c. All right. Antiderivative, moving right along. All right, so let's see if you've come up with a rule yet. Okay, here's the rule. Capital F, and this is important. This is just kind of a notation. Capital F is the antiderivative of f. Lowercase f, kind of italicized. Okay, so in this situation, this would be my f over here. This is the antiderivative. And then we're going to say f prime of x equals f of x. All right. Now, here is, I live in a house of men. I apologize. I'm going to take the collection of all antiderivatives. So the collection of all antiderivatives is written like this. The integral of f of x dx. That's what the integral is. It's the collection of all the antiderivatives. If I'm finding the area under the curve, I'm basically finding the antiderivative, meaning this is my derivative, what was the function that was there before that. So this is also called the indefinite integral. All right. We've been doing definite integrals. Now we're doing indefinite. Okay, so this is also called the indefinite integral. I have cat fur everywhere, y'all, of f. Oh my gosh, get the cat fur away. Okay, and I'm going to underline indefinite integral of f. Here's what it's going to look like. I think you guys will really like this part because I feel like the derivatives, you guys are like, yes, derivatives, I understand that. All right, ax to the nth power dx. Okay, that's what I give you. You need to undo this, meaning what we've just been doing. It's the antiderivative. So here's the rule and how it's work. I take a, I divide it by n plus 1, and then I say times x to the n plus 1. Okay, that makes sense because we're doing the opposite of what the derivative is. So just as a side note, I'm going to come over here and remember the derivative is a times x to the n. The derivative is a times n, and now we're going to divide an x to the n minus 1. So I need to increase this by 1, and then instead of multiplying, I'm going to divide by whatever this is. All right, and one more thing. When you're taking the indefinite integral or the antiderivative, you've got to say plus c. Now, c can be any constant. Okay, c can be any constant. And guess what n cannot be equal to? -1. Because if it were -1, I would get 0 in the denominator, and that would cause all kinds of issues. All right, now down here, I put some notes. Let me move this up just a little bit. And you can take a second and kind of look at those. So, the function capital F is the antiderivative of f if f prime of x equals f. The collection of all the antiderivatives of the function f is denoted as this, which is what we already put up there. This is also called an indefinite integral. Now that's everything we just wrote is right here, but I just wanted to write it as well. Okay, exam tip. The formula booklet gives you this formula without the coefficient. Okay, so here's my formula without the coefficient, meaning it doesn't put the a in the front. You're going to get the same answer, but it doesn't put the a. Important. I'm going to highlight this and let you look at that for just a second. This is what I wrote. Where c is any constant, n does not equal -1 is an integer. Okay? I think when you're doing the indefinite integral, it is much easier to put the a in the front and put it on top. I feel like that is something that they don't give you that actually would be a little bit easier if they did, and it's okay. We're going to make it work for us, but it's just something to definitely note. Okay, so here we go. Notice there's no boundaries. This is an indefinite integral. Find the integral 3x to the 4th dx and 3 over x to the 4th dx. Okay, so let's take this first one. Let's take the indefinite integral 3x to the 4th dx, and let's label what we know. We know that a in this situation is 3. We know that n in this situation is 4. I find it so much easier if I actually label everything. Okay, so I'm going to put that formula that I set aside back up here. So the formula says that if you have the integral, and if you've already got it handy, go ahead and you can write it, x to the n dx, it equals a over n plus 1. You won't need this formula for very long because you'll kind of memorize it. Okay? Here we go. This is going to equal 3 over 4 plus 1 times x to the 4 plus 1. So that's going to be, I'm just going to come down below actually. 3 over 5 x to the 5th. All right, try the other side. Oh, what did I forget? Yep, hopefully you caught it, plus c. I remember when I was first learning calculus, this was some of my favorite stuff to do. I loved doing integrals. Calculus 2 was all about integrals, a whole mess of rules we had to memorize. All right, so I'm going to do this one. So I'm going to say the integral 3 over x to the 4 dx. I'm going to say that a, in this case, is 3. And n, in this case, ooh, be careful. It is negative 4. Where did I get negative 4? Remember, if you're doing derivatives, it has to be written in this form. You can't solve it any other way. All right, so that's going to be a, which is 3 in this situation. So we're going to have 3 over n plus 1 times x to the n plus 1. That's 3 over negative 3 x to the negative 3. That's a lot of 3's. That's going to be 3 divided by 3 is negative 1 x to the negative 3. Now, I could change that, and I could say negative 1 over x to the 3rd. I'm going to let you look at that and make sure you agree with that. All right, so here's what we're going to do. We are going to go down here and do these other ones. And we're going to do a whole mess of antiderivatives. Okay, so here we go. I'm going to follow that rule. I've got my rule up here at the top. In fact, I'm going to highlight it on mine. It'll help me find it a little faster. Here's my antiderivative, my indefinite integral. I'm going to be using that constantly and referring back and forth to that. So what I recommend when you're doing these, label this a is 7, n is 3. So I'm going to say 7 over 3 plus 1 times x to the 3 plus 1. So this is 7 over 4 times x to the 4th plus c. Okay. All right. The next one, I'm going to say a equals 1/5, n equals 2. So I'm going to have 1/5 over 2 plus 1 times x to the 2 plus 1. This is 3, so it's 1/3 over 3, which is 1 over 15, x to the 3rd, plus some constant that I don't know what it is. If they gave me a point on that line or that curve, I could find it. But since I don't know it, I can't do it. All right, here we go. A equals 4, n equals negative 3. All right, so that's going to be 4 over negative 3 plus 1 times x to the negative 3 plus 1. So that's 4 over negative 2. 4 over negative 2 would be negative 2 x to the negative 2 And I'm just going to say plus c. I'm not going to simplify that algebraically. I'm just going to leave it. All right, I'm going to just give you the next ones of these. You can go back and work them. If you are watching this video and you have questions, you can come back and ask me. So on this next one, I got negative 5 over 2 x squared plus c. The next one, I got 8x plus c. The next one, I got negative 2 over 3. And I got x to the third on the bottom plus c. Plus 1, yeah, that'd be 3. Okay, and then this last one, I got negative 1 over 7x plus c. Okay, for some reason that one doesn't look right, so I'm gonna go ahead and work that one. So let's see, this one, n would be 2. Nope, sorry, a. A would be 2. N would be negative 4. So I would say a over negative 4 plus 1 times x to the negative 4 plus 1. That would be 2 over negative 3. Oh yeah, that's right. That's negative 2 over 3. X to the negative 3. So I'd move it down because, okay, yeah, that is right. Okay, it's right. I just didn't think it looked right. All right. Where are we at? Oh, hey, that completes that page. Moving right along. Okay, 27. And I need to check. I think that is your check for understanding. No, it was not. Okay, so here we go. We're going to work this one. This one's a really, really fun problem. I'm hoping my timer is still working. So I'm going to actually... Okay, I love this problem. All right, so I still have cat fur everywhere. Okay, so here's what we know. We know that f of 1 equals 1. We know that f prime of 3 equals 3. And we know that f double prime is how you read that, equals 4x minus 4. Find the constant term of the cubic. Okay. Double prime means that they have done the derivative twice. All right? So let's find f prime. Okay? So f prime of x, well, remember your rules. On this one, we're going to undo this one. So that means if I undo this one, it would be something like, what do I want to say? A would be 4. In this case, n would be 1. And that's just for this first one. And so if I undo that, that would be 4 over n plus 1 x to the 1 plus 1. Minus, what about 4? Well, there must have been an x there because when you take the derivative of this, you would just get negative 4, which is what I had right there. So let's simplify this. So f prime of x equals 4 over 2 would be 2x. That would be squared minus 4x. And you have to put the plus c. Okay, so here's the really cool part on this one. You know that f prime of 3 equals 3. So if you plug in the 3 for the x, you get 3 for the y. What do I do there? If I know that ordered pair is on this function, can I figure out c? I know the y value, f prime of x would be our y. I know that x is 3. I can figure out c. So here we go. 3 equals 2 times 3 squared minus 4 times 3 plus c. All right, so 3 equals 2 times 9 would be 18, minus 4 times 3 would be 12, plus c. 18 minus 12 would be 6, so that's 3 equals 6 plus c. I'm going to subtract 6 from both sides. 3 minus 6 would be negative 3 equals c. That means that f prime of x actually is 2x squared minus 4x minus 3. That's f prime. Okay? I'm trying to find f of x though. I'm getting there. So let's find f of x. Take the antiderivative of this. Well, I need to bring 2 and bring it down. I need to go the other way. So I'm going to say on this first one, n would be 2. I'm sorry, a would be 2 and n would be 2. A would be 2 and n would be 2. So I'm going to have something like a over n plus 1 times x, which is 2, to the 2 plus 1, minus 4 over 1 plus 1, x to the 1 plus 1, minus 3. I'm going to hope it was. Okay, I'm pretty sure it was. It did that earlier too. F of x equals 2 over 3 would be 2/3, x to the 3rd, minus 4 over 2 would be 2, x squared, minus 3x, plus c. Here's what I know. I know that f of 1, when you plug in 1 for x, you get 1 for y. Meaning I can plug those values in. 1 for x equals 2/3 times 1 cubed. Minus 2 times 1 squared minus 3 times 1 plus c. 1 equals 2/3 minus 2 minus 3 plus c. 1 equals, let's see, negative 2, and that'll be 2/3 minus 5 plus c. I'm looking to see if I already have this work. I'm trying to avoid that fraction. I'm going to add 5 to both sides and get 6 equals 2/3 plus c. Okay, so I'm going to subtract 2/3 from both sides. I'm going to think of it like this. 6 would be the same as 18 over 3, because that would reduce to 6, right? 18 divided by 3 is 6. I'm going to subtract 2/3 equals c. 18 minus 2 is 16 over 3, and that's my c. So, find f of x. Well, now I know. F of x equals, I know this value here, so here's my f of x. It was 2/3 x to the 3rd minus 2x squared minus 3x plus 16/3. That is what the original function is. That's not hard math, y'all. That is algebra. That is a whole bunch of algebra. Okay. So I want to give you some properties here. I don't know if I have a check for understanding inserted in the antiderivative, but go check, because I have a feeling I probably put a check for understanding in there somewhere. All right, I'm going to stop this one here, piece together those videos, and then I'll do the integral properties.